All right, so in this lesson, we're going to talk about area under a curve in Chapter 10 of your course. But by way of just an introduction, what we're going to do is we're going to talk about the area of a trapezoid, because this sort of leads us into finding the area under a curve. And so the area of a trapezoid is something we want to make sure that we understand. A trapezoid, of course, is it's quadrilateral. Okay, it's got four sides. Two opposing sides are parallel. Okay, so these two are parallel. These other two sides are not necessarily parallel. If they were parallel, we would have a square or a rectangle. But we're dealing with trapezoids, which these are not parallel sides. Okay, so in this diagram, this is a trapezoid. That's what it looks like. It's important to note that the height, okay, is not the length of any one of these sides here. It is the height from a point on one of the parallel sides to another point on the other parallel side that forms a 90-degree angle. So it's the direct kind of altitude here of this shape. So that's the height. Okay. All right. If we take a look at a trapezoid here and draw it like this, what we can do is we can view it as two separate triangles. So here is one triangle, right here. Okay. And here is the other triangle, right over here. Two separate triangles. Okay, I'm sorry, this outline is a little bit off the lines there. But we have area 1 and area 2, and if we add those two areas, we would get the area of the trapezoid right here. And so, of course, what we know about triangles is that the area of a triangle, the formula is 1/2 base times the height. And so for this area 1, this triangle 1 here, 1/2 the base is 1/2 of b times h. For this second triangle, we have 1/2 of a. If we treat this as the base and the height of the triangle, right here, okay, from the base to the height of the opposite vertex here, then we have 1/2 a times h. You factor this out and you get the general area of a trapezoid. So 1/2 height and then times the sum of a plus b. So this is the area of a trapezoid. Very important. The example they give you in the textbook here is looks like this, and it asks you to find the area of this trapezoid right here. Right? Area right here. And what we can see is that this is indeed a trapezoid. Now you're thinking, well, where are the two parallel sides? Well, they aren't on the top and the bottom, but they're here and here. Right? And so we could draw this trapezoid that looks something like this. If we just tilted it on its side, it would look something like this. And so here's A, and here's B, and here's height. So that height, of course, is this distance between 1 and 4. And the A would be this distance right here. And of course, because this is a function line, really this height is f of 1 right here. Right? And this height here is f of 4. And that's what they've done here. F of 1 is 1 plus 1 is 2. And f of 4 is 4 plus 1, or 5. And so the area of this shaded region, really we can treat it as a trapezoid, and the height is the difference between 4 and 1, that's 3. And the sum of the two sides would be 2 plus 5. And so 1/2 height times a plus b, you get an area of 10.5. Okay, so the important thing is to view this shaded region as a kind of a tipped over trapezoid, where this side right here is the height. Okay, super important. So that's going to be a kind of a prevailing theme here. And so if we come to our examples, if we want to calculate the area of this trapezoid here, or the area of this shaded region, we can treat it as the trapezoid. And here's the area of the trapezoid, 1/2 the height times a plus b. So the height of this trapezoid would technically be this distance here, the difference between the two x's. And so you have 1/2 times the difference between the two x values that are given, right here and here. And then the sum of this a and this b would be f of x1 plus f of x2. So if we were to work this out here, it would look like this. A equals 1/2. The difference here is 4 pi over 6 minus 1 pi over 6. And f of x1, okay, so y is sine of x. And so really we have, now, okay, it's adding, so it doesn't matter which one you put in first, but this would be sine of pi over 6 plus sine of 4 pi over 6, which also can be written as 2 pi over 3. Okay, so in agreement here so far? We good so far? Everyone connecting the A, the B, and the H with this diagram here? Okay, so again, if we have this at 1/2, and we'll calculate the area and we'll write an exact value. I guess we won't do decimals. We'll do exact value. It's always best if we can. And so 4 pi over 6 minus 1 pi over 6 would be 3 pi over 6 or pi over 2, right? 3 pi over 6. All right. Now, when we're looking at this right here, it might be good to go to the unit circle. If you still have one handy, I'm not sure if you do. But if we look for the unit circle here, we were looking for pi, what was it, pi over 6? And so the sine of pi over 6, do you remember which value is pi over 6? Which one of these? Or sorry, which value is sine? The first one or the second one? Second one, yeah. Okay. So for pi over 6, sine of pi over 6 is 1/2. And the sine of 4 pi over 6, which we said was really, it reduces to 2 pi over 3. Right? So 2 pi over 3 is over here, and our sine would be root 3 over 2. Okay, did you guys use exact values when you did this? Yeah? Okay, root 3 over 2. So root 3 over 2. Okay? Alright, so as we continue here then, that's going to be pi over 4 times 1/2 plus root 3 over 2. That's going to be equal to, this is pi over 8 plus pi root 3 over 8. And you could just write that as one term, I guess. Pi plus pi root 3 all over 8. Okay, so look back real quickly. Does that look right? Miss anything there? You guys in agreement with that? Did you have that as an answer? Okay, so that's the area for 1A. Okay, so if we look at number B then, letter B. So the area, okay, for B, if we talk about the area here, our trapezoid, again, a little bit on the side here, right? It's kind of tipped over. These are our parallel sides right here. And so this would be the height, the difference in the y values this time. And then one would be A and one would be B, I guess, right? Okay. So I guess the trick would be to find, I guess, this sort of A value and this B value. Now, is this 1 right here? Does that line up perfectly? It sure looks like it does. Well, what happens if we have sine to the, so it says sine to the -1 of x there, okay? And we were assuming that that is sine, 1 over sine to the x. Is that right? I'm not sure. They said cosecant. They would have said cosecant maybe if they would have meant that. I'm just wondering, did you guys try the cosecant or try 1 over sine x, and that way you got your value? Okay. So maybe what they meant was actually the inverse of sine as opposed to the reciprocal of sine. Okay? Okay. So in that case, so there is a difference between cosecant x and sine to the -1 of x. See, cosecant really is sine to the sine of x to the -1, and sine to the -1 of x, I believe is also called arctan. That's what this would be. One way you could figure that out, whether this is cosecant or whether it's arctan, is you could graph it. Okay, if you have a graphing calculator, you could graph it just to check. Say, Okay, I'm going to do 1 over sine x. I'm going to graph that. Then I'm going to do sine to the negative 1x. I'm going to graph that, see if it looks like either one of these. Okay. So just to reiterate this on the calculator, this is 1 over sine of x. And then if we were to do sine to the negative 1 of x, we get this graph that we're seeing here. So this is certainly the one we're looking at, not this one. Okay, so that's a way you could double check that. Well, I guess suffice it to say that if they mean 1 over sine, they'll write it as cosecant. Okay, so if you see it like this, you know it's the inverse. Okay, all right, so sine to the negative 1. Okay, so I guess that that might help to find these x values here. So the area is going to be then, I'm tilting my head here, look at this sideways. Okay, so it's 1/2, and the height would be, right, pi over 2 minus pi over 6, right, for this this height here. And then we need to find A and B. All right, so when we're looking for this x value here, it's a little tricky. But if you have, this is the x value you're looking for, right? And what's the opposite of the inverse of sine? Which is just sine, right? So if you take the sine of both sides, like this, that undoes this sign, and so you just get x over here equals sine of pi over 6. Okay? So sine of pi over 6, then you can go to, whoops, not that one, your, right here, sine of pi over 6, a unit circle, and it should be 1/2, does that sound right? So this is 1/2 here, plus, and then sine of, using the same logic, sine of pi over 2, which is what? 1? Pi over 2 here, coordinates 0, 1, there's your sine value, 1. Okay, so then area is pi over 2 minus pi over 6, that's 4 pi over 12, which is pi over 3. So that's pi over 1 over 2 times pi over 3 is pi over 6 times 3 over 2. Right? Am I doing this right? 3 pi over 12, which turns out to be pi over 4 for an area.